plus b into this is x square minus x into 1 plus x square plus c into this is x plus x cube first multiplying by x then by minus 1 is minus 1 here minus x square here is a plus d into x square minus x this one plus e into x minus 1 more times. This is x equal to here a into, let me write in chronological order, descending order, x square plus twice x square plus 1 plus b into, this will be x4 if I multiply by x square x4 minus x cube, okay, by minus 1 then it will, sorry, by plus 1 then it will be plus x square minus x only by 1 plus by x square x4 minus x by 1 then x square minus x. They are already in ascending order, sorry, descending order, okay, or decreasing order. Plus c into, let me write first x cube minus x square plus x minus 1 plus d into x square minus x plus e into x minus 1. This is equation number, let me take first here and let me drop others. So this one also let me drop. Finally we have obtained this equation number 1, okay, after multiplying by the denominator of the left hand side on both sides of this equation. This is what we have obtained. Now let us discuss about now converging coefficient. Here in this case, I mean in case of repetition of quadratic factors, we have to just equate the coefficient, no other solution is required. Equating or comparing, equating coefficients of x4, x cube, x square, x and constants, coefficients of x square, x appearing on both sides, appearing on both sides of 1. This equation number 1. So now let me first take x4. The left hand side here 0, no x4 here. Okay, so this is 0. Here it is a into x4, b into x4, which is b only. Let me take second equation. Now x cube, left hand side 0. No x cube here, there is no a doesn't contain x cube, b contains, this is minus b into minus x cube, plus c also, plus c is there, x cube, okay. Then third, equating coefficient, this is x square, coefficient of x square, left hand side no x square 0, it is twice a, 2 into a plus b, this is plus b here, minus c, okay, plus d and d. This is your equation number, right? This is the fourth one. Then with coefficient of x, this is 1 here. Here it is no x. Here it is x minus b, and then plus f plus c into x. Okay. Then minus d, no problem. Then plus e. Now constant coefficient also. Here left hand side 0, no constant. In this case a into 1, no b, doesn't b contain, c contains, which is minus c here, d doesn't contain, e contains, which is minus e into minus 1, that means constant coefficients. Okay, so these are the equations which we have to solve. Now if I solve these equations, let me check. Okay, this is b minus c, a minus c. Okay, now in this case, if I solve these, this is a and b and okay, we can solve c. If I add these two, adding this is, let me take this is the sixth one, second, third, fourth, fifth, sixth. There are 5 equations, 1, 2, 3, 4 and 5. So adding fourth and fifth, adding fourth equation and fifth. We get what do we get here after adding these two? Here A no B is there minus B plus B cancel out C minus C cancel out minus D plus D cancel out. Only twice A plus B and equal to 1 here 0 plus 1 is we are adding. Okay, fourth and fifth. Here 0 plus 1 is 1 in the left hand side. The right hand side we have twice A. This B and B we cancel out C C D D minus D plus D plus C minus C minus B plus B. Okay, so they are cancelled out plus E. This is equation number, let me take 7. The sixth. Okay. Now A and E, any other A E. Okay, so here it is. A B. If I add these two, this A plus C, here the A plus C, A minus C. Okay, that can be then solved. Now if I add these two, first and second, adding second and third, we get the left hand side we have 0. 0 equal to here B and B cancel out. Only A plus C. A plus C equal to 0. Then obtain. Now in this case, if I add this, so let me take eighth equation. Adding C and okay. C will cancel A and E. It will be okay. So adding this eighth one and sixth, we get adding this one and this eighth. So we see here A plus A twice, but C and minus C cancel out plus C and minus C. The left hand side we have 0. 0, this one and this one, 0 in the left hand side. 0 equal to twice A minus E only. For this C and this minus C cancel out. For that we did this twice A plus E. Okay, twice A minus C equal to 1. Okay. This twice A plus E equal to 1 and this twice A minus C equal to 0. So adding these two, we get value of A. 4A equal to 1. So adding this is minus 1 let me get. So adding 9th equation. Now let me look at this. Need of this now. Okay, so adding this 9th one and this 7th one. So adding 7th and 9th. This 9th we get. Here we see minus E plus E cancelled out. Plus twice A, 4A. Here 1 plus 0 is 1. So 1 equal to 4A. That means A is equal to, simplify that, A equal to 4. A is obtained. Now C can be obtained. A equal to, C equal to minus 1.4. C equal to minus 1.4 from this, from 8th one. So C equal to minus 4, minus 1.4. Now C is obtained. Now E we can obtain here. This is 1.4, 1.2, 1.2, then E from 7th. From 7th, 1 equal to 2 into 1.4 is value of A 1.4 plus E. This is 1.2. 1.2 if I subtract from 1, it will be half only. E is equal to half 1.20. Okay, so E is obtained now. Okay, C is obtained. AE. Now let me talk about B here. Because C is obtained, B will be plus B equal to C or D equal to C here. Whatever C value is there, B is same value because minus B equal to this minus C or C equal to B. And B is equal to C is equal to 1.4. This one minus 1.4. Yeah, it is minus 1.4. Yeah, it is minus 1.4 here. Here I have to add here minus 1.4. C is minus 1.4. So A is 1.4. C is minus 1.4 from this. So B and C both are same minus 1.4. Now D is only left over. So D can be calculated from either this or this. Let me take from this equation. From 4th. from fourth, we get 0 equal to 2 into A is 1.4 plus B is minus 1.4, it is minus 1.4, minus 1.4, minus C is plus 1.4, so it's minus minus plus here minus minus plus C is minus 1.4, so these two are, this is minus 1.4 plus 1.4, C is here, okay, that is that we have obtained. Alright, so plus D. What we get is these you can out 1.2 only, D equal to 1.2. So this D is equal to minus 1.2. Reason this is 1.2 D. 1.2 take to this side, so D is equal to minus 1.2. All the constants are A, B, C, E, D and E. Let me write here. A is equal to 1.4, B is equal to minus 1.4, C is also minus 1.4, D is equal to 1.2, minus 1.2, E equal to 1.2 positive. Okay, so all the constants are obtained. Now finally we can take the partial fraction of this equation. That will be equal to this. Let me write them here. Finally, what is the partial fraction of this equation? Which will be equal to A is 1.4, 1.4 into x minus 1, this one. Now plus B is minus 1.4, C is also minus 1.4. Let me take minus 1.4 common, it will be x plus 1 upon 1 plus x square. C and B both are same, it is 1.4, we have taken minus 1.4 common, x plus 1 will be left over. Plus D is 1.2, sorry, minus 1.2. So this is minus 1.2 into x plus 1.2 upon 1 plus x square whole square. Alright, so let me separate them and then integrate for integration of x upon x minus 1 into x square plus 1 whole square into dx. This is equal to 1.4 sine of integration 1 from x minus 1 into dx minus 1.4. This one. Let me separate them. This will be x upon 1 plus x square into dx minus sine, sorry, this is minus 2.4 sine of integration 1.1 plus x square only into dx. Here it is. Let me take minus 1.2 common out. So it will be x upon 1 plus x square into whole square into dx. Then plus 1.2 sine of integration 1 upon 1 plus x square whole square into dx. Okay, so in these two, between this one and this one, we can do what? These two values. And this is simple, so tan inverse x only. Okay, so these two, if we take 1 plus x square, let me write here 1 plus x square whole square, this is that one. In this case 1 plus x square equal to what are this I1, this is I2, let me take this is integration, it is integrated as log of x minus 1, the first one. And second, this one and this one, we have to assume x 1 plus x square equal to t, differentiating it with respect to t, differentiating it with respect to t. So we get this is twice x into dx upon dt equal to 1 on x into dx equal to dt upon 2. Substituting this in these two equations where x is appearing in denominator, so x dx upon equal to dt, x dx equal to dt, it will be this one minus 1.4 into 1.2 into dt upon t, first one. Then this will be integrated with minus 1.4. Integration of this is simple tan inverse x. This one integrated. Minus in this case, as I am talking about, into 1.2. dt upon t square. This is t square here. Okay, now in the last one, this is plus 1.2. Here we have to assume the last one. Let me first write it as 1 plus x square into whole square into dx. These are being integrated. What is this? 1.4 into log of x minus 1 to 1.8 into log of t. T is 1 plus x here. Okay, this is minus 1.4. Tan inverse x to minus 1.4, and this is minus 1.4. This will be plus 1.t here. That means upon 1 plus x square. Which one? This one. Why? It will be t raised power minus 2. Integration will be t raised power minus 2 plus 1 and t raised power minus 1 upon minus 1. Minus 1 will make it positive. This positive here. 1.4. Okay, and this will be 1 upon 1 plus x square only. Now the last one, this part. In this, again we have to assume, let x equal to, or put x equal to tan theta, before dx equal to sec square theta into d theta. If we have to differentiate with respect to theta, so it will be dx upon d theta equal to sec square theta. Take d theta to that side, put dx equal to sec square theta into d theta. Now let me substitute here. It is sec square theta into d theta. On sec square theta inside, because 1 plus tan theta to right. 1 plus tan square theta whole square. Okay, the last one we are talking about. All these are integrated. So this one integration will be what? If I take out of the log 1.8 common, we 2 into log of x minus 1 plus 1 minus log of 1 plus x square. Okay, this is minus 1.4 tan inverse x, and this is plus 1 upon 4 into 1 plus x square is value. What about this? This is plus 1.2 into, here it is sec square theta inside the bracket, but that whole square is sec 4 theta. It is sec square theta cancelled out. 1 times sec square theta will remain d theta. If we again cos square theta, this I have to repeat them as it is. Okay, all these values are here. Only I have to write this 1.2 into cos square theta into d theta, just we did in the previous question. Okay, so again this is to be repeated, that you write here. So finally the answer is, let me write it here. Therefore this is equal to integration of this whole equal to 1.8 into, this is twice for the log x minus 1 whole square upon this the log of 1 x minus 1 whole square upon 1 plus x square. Why? Log n minus log n, but this twice log x minus 1 is log x minus 1 whole square will be taken as the power. This is minus sign, so log n minus log n, then is this log x minus 1 whole square upon 1 plus x square. This is solved. Then minus sign 1.4 tan inverse x. If I take this as common 1.4 minus 1.4 out of these two, it will be minus sign. If I take common, it will be minus sign 1 upon 1 plus x square on d. These two are also taking 1.4 common, minus 1.4 common, so that this sign is positive into negative. Now the last one is, here cos square theta is to replace 1 plus cos 2 theta in 1.2 kind of integration. 1 plus cos 2 theta into d theta, okay, upon 2 here. It is again integrated, the same value plus 1.2, sorry 1.4 here. Now is 1.4, and it is d theta. One integration is theta here. I'm sorry, let me write here d theta plus this is 1.4 cos 2 theta into d theta. This integration. Now we have to integrate this again. This is plus same thing. Okay, everything is repeated, only the last these two sections we are doing. This is theta only plus 1.4. This is sine 2 theta integration. So sine 2 theta is again integrated. This is 1.4 tan inverse x. Why tan inverse x? Because theta becomes x becomes tan theta equal tan inverse x. Plus this is 1.4 into 2 sine theta into cos theta. Will cancel out. This is plus 1.4 tan inverse x plus 1.2 of sine x we considered as x upon under root plus x square as in the previous question into 1 upon under root 1 plus x square plus take constant here. Let me take finally why this was the triangle AB frame and x equal to tan theta. Same thing we did in the previous question. Theta here, this is right angle, hypotenuse under root 1 plus x square. So x here is equal to 1. Therefore, hypotenuse square will be 1 plus x square is square root of 1 plus x square. This is 1 plus x square equal to this is 1, this is x. Okay. Finally, these values sin theta is x upon under root 1 plus x square. Cos theta is 1 upon this cos theta sin theta. Okay, so we have substituted them. So under root square root in the denominator is cancelled out. Finally, these two values are of similar type. Let me take plus this is 1.4 tan inverse x plus it will be x upon under only 1 plus y into 2 into 1 plus x square plus j constant. This value is and the previous this value this is minus 1.4 tan x cancel out I think. Okay, so this is minus 1.4 tan inverse x plus 1.4 into 1 plus x square. Okay, this value let me multiply because these two are cancelled out. All negative or the positive same. This is 1.8 here log of x minus 1 whole square upon x square plus 1. Okay, only so this value it was here the minus sign. This is cancelled out. This value is only left over. This is left over and the last one. So let me write afresh. This is 1.8 log of x minus 1 whole square upon 1 plus x square. This value is plus 1.4 into 1 plus x square. Okay, and this is value plus x upon 2 into 1 plus x square, and this is plus k constant. This is plus k constant. So only these values are 1.4 tan inverse x, this 1.4 tan inverse x cancelled out. So this was integration as okay, and the last one is this value 1.4 tan inverse x is theta. Okay, so that is also these two are cancelled out. This 1.4 okay. And finally this is answer. Question number second we have done. Okay, so let me take next question. Question number third. What is question number third? See? So this is the process of solving these questions. Now let me talk about the next question. So question number third, what is it? Question number third here. So it has okay x cubed plus x plus 1 divided by x square plus 1 whole square into x square plus 2 only. Yes, again quadratic proper fraction. So this is x4, this is x, so x6. That's the proper fraction for that. Again, we assume we divide into partial fractions like this, take a constant x square plus 1 whole square into x square plus 2. Let me take this is equal to a upon ax plus b, the first one. This is x square plus 2, quadratic factor, plus this is c.x plus d on x square plus 1 plus ex plus f divided by x square plus 1 whole square. Okay, this is repeated 2 times, but this is another quadratic factor which we have written first time, okay, or in the first one. So ax plus b plus that whatever number of times repetition there that will appear that times. Okay. Now let me again multiplying this. So multiplying this equation, multiplying this equation by this equation by x square plus 1 whole square into x square plus 2 on both sides, on both sides of this equation. Multiplying this equation by on both sides. Okay, that is already written. Now let me add it further. So this x cube plus x plus 1 equal to a into x. Okay, that will be, let me write this equation. So it will be x square plus 1 whole square plus b into only x square plus 1 whole square plus c into x into x square plus 2 into x square plus 1 plus d into x square plus 2 into x square plus 1 plus e into x into only x square plus 2. X square plus 2 is x square plus 1 whole square cancel out, only x square plus 2 will come, and plus d, sorry, x into only x square plus 2. Here x was there. Now further let me express this or expand the whole equation. The expansion of this will be, for the expansion, a into, let me still write ax will be x4 plus twice x square plus 1 whole square of x square plus 1. This is there. Plus b into, this is clearly one time on x square plus 1. This is b plus c into x into this. First let me write c x only. It will be x4 plus x square plus twice x square plus 2 only. Okay, no problem. Now plus d into x is still there. So it will be d into x4 divided plus 3x square plus 2. This x square plus 2x square plus this term will be repeated here in d also. D, these two are multiplied. Only x is extra in c. Plus d, sorry, e into x into this, that is x cube. Because this is x cube plus x twice x. X cube plus twice x. This is there. E is clear, D is clear. Now C is further multiplied and A is also further multiplied. A into x, this into x5, 2x cube plus x1 plus B into the same value repeated, twice x square plus 1 plus C into, this is x5 plus x cube, okay, plus x cube plus twice x cube. So this will be, we write one time. It will be 3x square, so it will be 3x cube with 3 times x cube, 3 times x 3x square into x 3x cube plus time 2 into x plus 2 into x, and this b x5 3x cube plus twice x no problem plus e for d. It's a d here. D into x4 2x square plus 1 or 2 plus 2 here, not 2 into 1, okay, and it's 2 here plus 2, this is plus 2, then plus e into x cube plus twice x, last one. Okay, so this is the whole value. E into x, sorry, plus x is also this, I'm not writing that, that will this. plus f here plus x square plus 2 here also f is x square plus 2. F is also there on sorry. F here it was, here it is. Finally, this is the one equation because the left hand side is x cube plus x plus 1. So the last equation, you take this as the first equation. That brings up the whole above part. Okay, finally, let me frame the equation now by equating coefficients. Now by equating coefficients, what do we get? Equating coefficient of this equation. Equating coefficient of x5 here, x4, x cube, sorry, x square, x and constant coefficient of this, and constant of 1. We get even the one equation here. Equation number 1. Okay, let me equate the coefficient x5 here, left hand side is 0, no x5. Then in the right hand side, a is there, c is there, and plus a plus c. The first, second equation. Okay, a and c here. A x5 and c x5, no problem. Then second equation, x4, let me take coefficient of x4 here in the left hand side 0. x4 only b is there, a plus b. Then d is also there. This is d x4 and d. b plus b, this is third equation. This is equation number third. Then let's talk about next. For the next equation. Okay. x4 here. So d is third equation. Equation number third. Then this is x4. Now x cube. Coefficient of x cube in the left hand side is 1 here. Is equal to, here it is, twice a. Okay, no, this is 3c, 3 times c here. No d, but c is there. E into x cube only. This is your fourth equation. Now let me talk about fifth equation. So this is x5, x4, x3. Now x square, no a, left hand side is 0, no